Okay, welcome to going over the evaluating functions part of the test. We've been evaluating functions, right, and function notation for forever this semester, and this is just asking it in a little bit different of a way. So here we see that we've got a linear equation. Let's find the turquoise. So this is a linear equation, right, and this is an exponential equation. Let's go ahead and focus on the exponential equation first. Um, I think function notation is important, but so is knowing how to use a table function on your calculator. And that's what we're going to use for this. Go ahead and get this exponential function, get your calculator, get it up on the table, and all we're going to do is see if any of these points are part of the points that are on this graph. So when we see negative 5, 0, let's find an orange, that's the same thing in a table. That's right, the negative 5 is the x part of the point, and the 0 is the y part. So when you're looking at your table function, and do you see, when you go to negative 5 for x, do you see a 0 for y? I don't think so. No, you're going to see a very small number. Let's try the next one, 0, negative 5. So 0, negative 5, the point right here is the same thing as seeing 0, negative 5 on the table. And so when you're looking at the table for 2 times 3 to the x power, do you see, when you look at 0, do you see a negative 5 there? No, right? You see a 2. So far we're like, no, okay, that is not happening. All right, let's go ahead and try the next one. 0, 2. We just said we saw it, so we saw it. So 0, 2 is a point on this graph right here. And we'll put a little check mark here. So when we see 0, 2 on the table, that means if we're looking at a graph, right, 0, 2, we'll see that point on the graph. Okay, so let's go ahead and look at the last one, 1, 6. Is this going to work? 1, 6. Go ahead and look at that. If you look at a 1, do you see a 6? Absolutely we do, right? Because 1, 6 would be whoop, way up here, right? We're going to have something that looks like this and goes through, bloop, 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 if we graphed it. We don't have to graph it. We've got the table. So 2 points were on the graph or on the table of this exponential equation. And that's all you're going to do when you see it on the test, right? All right, let's go through and try to do the same thing for the linear problem. The problem with the linear problem, let's use pink. The problem with the linear problem is that we can't put this form into the calculator, all right? We always have to do y equals. So what we're going to have to do is we're going to stop and do a little bit of work. We've got negative 2x plus 5y equals 10. Let's go ahead. We want to get y by itself this time, not x. So we're going to add 2x to both sides. So we get 5y equals 2x plus 10. Or I could have written 10 plus 2x. Doesn't matter. Either way. Okay, almost done. I want to get rid of this 5. So I'm going to divide that by 5. I'm going to divide this term by 5 and this term by 5. So when we're adding, like, see how we did this, the first step, we added 2x. We added 2x just one time to both sides. When we're adding or subtracting, we just do it once on both sides. But when we're dividing or multiplying, we have to be very careful, because if we're dividing and there's more than, see how there's 2 terms here? 2x is a term and 10 is a term. We have to divide both those terms by 5. All right, so just a little reminder. Can't remember when was the last time we had to do that. So then our 5's cancel out. We get y equals 2x over 5, or if we want to write it this way, 2/5 x, either way. And then 10 divided by 5 is 2. All right, so right now, go ahead and put this into your calculator and look at the table, and let's see if any of these things work. All right, so let's see, our first number is negative 5, 0. Now, I don't have my calculator, so I'm going to do a quick little plug-in. Yes, you should see it, right? You should see negative 5, 0. That works for this. All right, how about 0, negative 5? When you look at 0 for this table, do you see a negative 5 in the y? You don't, do you? You should see a 2. So this one is the only one that doesn't work for both of them. We'll say neither. All right, so this is just a fun little thing on the test that is saying, hey, can you use your table function? Do you know how to use it? Do you know what to do when you don't have y equals, right? We know what to do. We just got to review that a little bit. All right, the second part of the test is what we've been doing all year with function notation. If it says find f of 4, we're going to take this equation and we're going to say, all right, f of 4 is just another way of saying what's the value, so what number are we going to get if we plug 4 in for x? So we're going to plug it in here, and we're going to, and you know what, I didn't like the way I just did that. I'm going to go ahead and rewrite f of x equals, I'm going to rewrite this, and then f of 4 is just saying plug 4 in for x. So we're going to do that. We're going to rewrite everything else. We're going to pick up our calculator, and we're going to get what 8 minus 5 is 3. So our answer is 3. So we've been doing this all year. We're good at this. And so if I'm going to rewrite this, and I want to know what's g of 5, I know we're going to plug 5 in for x. And then we're going to we're going to rewrite everything else. We're going to pick up our calculator. That's going to be what? 25 plus 12 gives us what? 37. And I think that's it. So that's going to be one part of your test that we are going to totally rock. All right, thanks for joining me.